I call it sort of urban mining, right? Any electronics that we can get our hands on, it's a much higher grade feedstock. So that's really why there's been so much movement in that space. We're really trying to just untap a lot of the resources we have here in a much more sustainable and economic way.
This is Energy Cast, and I'm Jay Downhauer. Today we're talking about a sustainable way to mine minerals. I've said it in the past, we are asking a lot of lithium. Less than 0.5% of vehicles currently on American roads are electric. We also want to back up a lot of our grid with lithium-ion batteries. And that's just lithium. My guess is rare earth metals are needed for wind turbines and motors for, again, electric cars. We need to get a lot more efficient and sustainable with our resources in order to achieve the energy future we've promised ourselves. My guest says they have a solution. They're tackling the issue on two fronts, conventional mining and what she calls urban mining. Let's start with the conventional mining. In episode 106, we learned how lithium mining can result in up to 70% of that lithium being lost during the refining process. My guest says mines where rare earth minerals are found can lose as much as 30% of the resources through tailing ponds. For urban mining or recycling, there's also issues. Batteries, electronics, old cell phones, you name it, are typically shredded up into a mulch called black mass. That's then sent to faraway lands where it's burned and sorted. Now, that isn't the step where metals are reformed into new products. This energy-intensive globe-trotting process has been the conventional means just to get these metals sorted out. The solution my guess has developed is an extraction process that requires far less energy and mileage. They've developed a solution they call electroextraction, which can separate and concentrate metals on site, whether it be mines out west or shredding facilities downtown. The mobility is key, since transportation is one of the limiting factors that keeps this kind of material from being mined or recycled. It's this local focus that could make for far more efficient extraction. My guest today is Megan O'Connor, co-founder and CEO of NthCycle, a metal extraction technology company based in Beverly, Massachusetts. Megan and her co-founder developed the electroextraction technology while at Yale and Harvard. They've been in business for about 4 years and plan to operate their equipment as a service. As Megan explains, NthCycle's name refers to their goal of creating a truly sustainable and circular ecosystem, where the batteries and critical metals we need can be recycled indefinitely with the aid of their technology. Speaking of which, having spent a little time in the water treatment sector, it's always fun to play what's in the magic box when it comes to technologies like these. I was still stumped. I hope you enjoy my conversation with Megan O'Connor. We're here with Megan O'Connor, co-founder and CEO of NthCycle. And Megan, I recently had a guest on to discuss vehicle to grid. And one of the points I made about lithium ion is I don't think you could build or source materials for a lithium ion battery pack within North America. Can you? That supply chain stretches around the world right now, right?
That's right. That's right. So I will have to agree and disagree with that point. So near term, we cannot. No, we do not have the resources here to supply the supply chain, I should say, in terms of the lithium ion battery critical materials we need. But we absolutely have the natural resources. And that's exactly what NthCycle is trying to solve, is trying to create a new refining process to access all the materials that we do have here. Because if we could access them, we would absolutely be able to have our own supply chain.
Yeah. And look, I know that people have had Nissan Leafs for a while, but I would say that we're really still in the first generation of electric vehicles, widely proliferated. And the batteries for those vehicles haven't been replaced on the oldest vehicles just yet. We should start seeing that within the next 5 years. What I'm getting at is we're not seeing a mass turnover of the batteries that have aged out. Are we ready for the recycling that would be necessary for that?
I think we're getting there. So there's a lot of companies out in the space, including Encycle, that are trying to develop the technology and even the infrastructure that's needed to recycle all those materials. Because you're right, we won't see a mass influx in terms of the volumes of available recycled material until at least 2030, if not 2035. That's why, again, near term, we are not going to have the critical materials to develop our own supply chain. But if we take into account the vast majority of capital going into a lot of these battery startups and companies that are trying to build out not just the recycling piece, but also the manufacturing piece, if we think of some of the larger startups in the space, trying to go all the way from collection to creating a new cathode, but also in the mining space, right? And that's something that Encycle does pretty uniquely, is going after any source of cobalt and nickel. If we focus on those two, not just from spent batteries, but also from mining, right? And sustainable mining, because we do have the cobalt ores in mines here. We do have the nickel ores. They just haven't been accessible because of limitations of technology and the really low grade ores that we have in terms of being able to transport them to refineries. Again, trying to create a strategy and develop new technology that can actually go and access those materials, I think, is exactly where this industry is starting to move.
Sure. And I've read up on recycling these batteries, but wouldn't necessarily claim to be an expert, but maybe you can help us understand some of the concepts. Essentially, when you're recycling, you're starting with something called black mass. Is that right?
That's right. So the way that batteries are recycled today, and I almost use recycling in air quotes because it's not really fully recycled yet, unfortunately, within North America. They collect the different lithium-ion batteries, they shred them down. So there's just a massive shredding process. You can imagine them throwing some packs or cells into a giant shredder. And then what comes out of that shredding facility is the black mass, which is considered a waste product at this point. It's really the mixture of the active materials, so the cathode and the anode. And so it's black, just again, because the anode is all graphite or carbon.
Yeah. And there are ways to refine that, sort out the lithium, cobalt, manganese, all those different components there. Tell us about what's out there now, maybe where you fit into this.
Yes, absolutely. So what happens to the black mass now is it's sold off into what's called pyrometallurgical facilities or smelting. There's big companies out there. There's a few in very, very northern Canada and then mostly overseas in Asia. They actually will take this black mass, they will burn all the carbon off. So it's a very carbon intensive process. They create metal slags and try to pull the cobalt and nickel out of that metal slag. So that's generally what's done today. Where Encycle fits in is trying to skip this very carbon intensive step and actually create micro refineries within North America that can more efficiently process this material wherever it's being collected. So whether it's ore or spent lithium-ion batteries and turning that into black mass, we take all those materials and we pull them out with just a very low amount of electricity. So our technology is called electro extraction. And you can think of it as an electrified Brita filter. So we've really just figured out a very smart, efficient way to electrify a water filtration system. And by applying those different electrical currents across that filter surface, we can actually pull different metals out into products that can be sold directly back into the battery supply chain. So again, helping to skip a lot of the very expensive carbon intensive steps that are required today to recycle those materials.
Yeah. And the previous technologies way back, you said they were shredding it up. Were they melting it down?
Yes. So they were burning it. But again, we only have one or two facilities within North America that can currently do that. We don't actually have much in terms of refining capacity within the United States. So a lot of the times it was shipped over to Asia to be burned or to be dissolved in acids with the various solvents that they use to pull these materials out.
That sounds extremely energy intensive to do that as opposed to your process, for instance.
Absolutely. Yes. It has a very large carbon footprint in terms of energy consumption.
It's a dry process.
Our process is a wet process. We use a small volume of acids, but our system fully recycles those. So we like to call it a closed loop chemical system.
Okay. The electricity, is it magnetizing? Is it basically pulling it out that way? I apologize if I don't understand my metal science.
No worries. So when we electrify this filter surface, there's small electrochemical reactions that are happening at the surface. You can imagine we're simply figuring out a way to make the metals that are solubilized in the solution to an insoluble form. So the electrochemical reactions help to actually pull the metals out as solid particles. And those are the solid metal powders that we can sell back into the supply chains.
I believe you mentioned two metals, maybe cobalt and nickel. If I was hearing you right, I didn't hear lithium. Is lithium what's left over?
That's right. Lithium is unreactive in our system. So we actually separate the lithium out, but don't create a solid product out of it.
I spoke to a company called EnergyX, and they had a process during the mining operations, the ones that are in South America and everything, where they were essentially just using a reverse osmosis unit to filter out the lithium. And one of the things it was able to do is keep the lithium and manganese from co-precipitating, if I understand that correctly. Is that an issue when you're on this end of the process, trying to pull that stuff out and reuse it?
That's a great question. We do not face that issue. So we can actually separate out the different materials and then separate lithium from those products itself. So we can create a suite of products rather than worrying about the co-precipitation, like you mentioned in other technologies.
Yeah, and I think it mentioned that your process used a filter press. I've had a little bit of experience with water treatment. In the fracking sector, I did a lot of recycling technologies, trying to make that process a little bit more sustainable. So is the filter press basically after you've separated everything out to kind of concentrate everything?
That's a great question. So we use a filter press in a couple different places, but the core technology itself is actually in a filter press. So that's how we've been able to scale quickly and efficiently, is actually using the filter press body or skeleton to put our core electrified filters into. You can imagine the filter press really just holds sort of the core technology piece of our proprietary process so that we can efficiently remove those materials. And then we also use filter presses in other parts of the process itself in the traditional sense, but we actually use it as well for our core technology piece.
Okay, so you're basically building your technology around an existing filter press, essentially, right?
That's right.
That's cool. Okay. I think one of the keys to any recycling process is energy efficiency, effectiveness, and I would say ease of use. You know, you're not going through 1,000 steps. So how does your process compare to that?
Yes, absolutely. And that is one of the first things we thought about was ease of use, ease of integration, right? Because as I mentioned before, transportation of these materials is one of the most limiting and expensive steps that we face in the recycling supply chain within the US today. And so we thought, can we develop a technology that's not only modular and can actually go on site where all these materials exist to significantly reduce the transportation that's required to recycle them, but can we also make it a much more energy efficient and cost efficient process itself? And so the answer is yes, we can reduce the overall energy that's required to pull these materials out by 60%. We can reduce cost by 75%. So it's a much cheaper way to pull these materials out. Again, because instead of having to use high temperatures or high pressures or vast amounts of chemicals and solvents to pull these materials out, we just use a very low amount of electricity that could come from 100% renewable energy. So a much more sustainable process with a much lower carbon footprint. So in addition to all those cost savings, we can also reduce the greenhouse gas emissions by 75% as well.
Megan, I'm wondering why the recycling isn't more widespread. I mean, is that one of the barriers? Maybe some of the other processes were a little bit convoluted, maybe not as energy efficient?
There really was no battery recycling market in terms of lithium-ion batteries. So, right, we've all known that there's been lead acid recycling for a couple decades now. But in terms of lithium-ion, right, there was really no steady stream, like you mentioned earlier, of batteries actually coming off and having a large volume of materials to recycle. And there was really no demand for it until the big electrification movement started, whenever we think that that may have started. A few of us probably think it started sooner than it actually did. But there was really no demand to recycle those materials. And we never invested in the infrastructure. So again, these massive refining facilities that recycle these materials today are $500 million, if not $1 billion to stand up. And they require a really large volume of materials, which again is why we don't mine a lot of the cobalt and nickel ores here, is because they're short life mines. It didn't make sense to invest this $1 billion into these facilities when we could just ship it overseas. Until we really were aware that it was a big national security issue, there was really no driving force or no momentum into investing any capital into this space. We're really excited to see that movement start to happen, not only from the government standpoint, but also from industry itself, right? You've seen sort of a massive influx of capital into not only the battery recycling space, because people are aware that this is going to be a massive waste management issue and we need more critical minerals, but also in terms of sustainable mining and really onshoring a lot of that refining capacity, which we had not invested in the past 50 years or so.
In reading about this, and I think you mentioned this at the very top, most of the focus was on waste streams for existing batteries, but you're also working with mining operations as well. Take us through how much is lost in mining operations that could be recovered and actually used.
It's very dependent on the different types of ores, but in general, up to 30% of the valuable material in the ore body can be lost in the traditional processes. So 30% of all those materials just lie in these waste tailing ponds, they call them, for decades, right? And it's just a big, you can think of hazardous waste pit with, say, like the cobalt and nickel, the rare earth metals, even copper, right? And golds, even those have very high losses. We could stick Encycle's technology on the end of existing large mining operations to help pull a lot of that sort of lost valuable material out. But we've actually also been looking into and talking to partner facilities around the US in particular, where there are newer mines, again, still in the permitting phase of people, again, trying to figure out, can we sustainably mine the different ore bodies we have here, right? Because you hear mining and you automatically think, really hazardous, expensive, dirty processes. But again, we're trying to bring a new lens to this, saying, okay, we need these materials or we will not be able to move forward on the clean energy transition. There's no way around it. We need those materials to do that. How are we going to get those, right? And again, recycling is a really critical piece, but even if we were to recycle 100% 100% of lithium-ion batteries in 2030. It's still only a fraction, like 10% of the total metal demand that we're going to have in 2030. There's a desperate need for new mining practices to come into the States to access a lot of the cobalt nickel ores. And what the big issue is, it's a very low-grade material. And they're very, in terms of the life of the mine, compared to what you'd see overseas, they're very short life mines. And so there's sort of been these untapped resources out in the West and the Midwest for decades because we just really could never figure out a way to effectively or economically refine them. So that's where Encycle comes in. We can actually go on site with these folks, upgrade that very low grade ore into a high grade concentrate that can then be feasibly shipped and put back into the supply chain. So we're really trying to just untap a lot of the resources we have here in a much more sustainable and economic way.
I'd have to think that they're probably most interested in the cobalt.
And then, nickel is actually rising to the top as well. It was actually just added to the US's critical minerals list. I believe it was last week.
I think the word is getting out about cobalt, how it's typically mined. It's pretty nasty business. Child labor, I think, has been thrown around. So anything to try to mitigate that would certainly be effective, right?
Yeah, the vast majority of our cobalt mining happens in the DRC, where, yes, like you said, there's a lot of child labor. It's extremely hazardous. There's a lot of what they call artisanal mining that happens, which is not necessarily regulated. People literally will go in and start digging with their hands because, again, it's such a high grade cobalt. You can do that. You shouldn't do that because it's quite toxic, but you can do that. It's a horrible practice that a lot of folks are trying to move away from and be able to actually trace their supply chains in that sense to make sure that they're not taking in any of that cobalt for their own products.
Right. I think that's really picking up a lot of steam. Megan, I think you mentioned we might not be completely circular, but you'd have to hope that maybe we might eventually get to a stage where a large amount of the raw materials we need for these batteries are in a cycle where we're not relying on foreign sources as much. Kind of like if we were recycling enough paper, we would just be continuously reusing that same paper as opposed to chopping down new trees, right? How close do you think we can get to that?
I think we can get there. And that's Encycle's overall vision, actually, is to create a world where all of the critical minerals that we need for this energy transition and beyond are already in circulation. Meaning, like you said, we can just continue to use these materials over and over and over again. And actually, going back to our name, right, Encycle, a lot of people ask me, what is the origin of that name? And it's truly like we believe we can reuse these materials unlimited or amount of times, because in theory, we should be able to get there. We'll have to do a little bit of mining, but the goal is to truly try to reduce that need as much as we possibly can moving forward.
Sure. And things like lithium, does that metal ever wear down? Can you just continually, forever and ever, reuse it for these battery packs?
In theory, yes, you should be able to reuse any metal an unlimited number of times. It's really just, do we have the technology or the ability to pull the lithium back out, or even any of the metals back out, right, with less energy than it would take to mine new material? And so that's really the balance that we try to strike, is you wouldn't want to recycle anything if it actually cost you more energy to do that than to mine raw material, which was what was happening for a very long time, right, until a lot of these new technologies came into the market. But now that there's much more sustainable ways to actually recycle these materials, I do see a path forward to reusing all these materials unlimited number of times.
Tell us a little bit more about your business model. You mentioned going up to existing tailing locations for mining, for instance, but do you also have plans maybe for building your own freestanding facility, or is it really just going where the scrap is?
Yeah, so we do not have any plans to build our own facility. Again, looking at the total supply chain here within North America and all the pain points, it was really in the transportation and the movement of these materials and not being able to access these because they're either in very remote areas where it's extremely expensive and hazardous, to add to that, to move these materials, or we just couldn't move them in terms of the economics. So we specifically designed the technology as well as our business model to be that modular sort of flex capacity, we like to call it, for materials that can't make it but need to make it back into the supply chain, so we can go and be that micro refinery on site to access as much of this material as possible. So yes, we only have projects lined up that we're actually going to go on site and provide a service to upgrade these materials from a waste product into, again, a valuable suite of products for our customers to then sell back into the supply chain.
The business model is you're doing this as a service, right? You come with your equipment, you have your own operators, right?
That's right. Yes, we're going in under a tolling model that we will provide the service basically of, we're going to own and operate the assets for you. You just pay us a fee per, say, kilogram of batteries or pound of batteries that we process for you.
And we're talking a lot about batteries, particularly lithium-ion batteries, kind of narrowing that conversation. But any technology like yours that could parse out these components in a very energy-efficient way sounds like it would be beneficial to several industries, like electronics. You hear about chip shortages. I've got things like a docking station for my computer I'm waiting forever to get. Have you looked at that as well?
That's correct. Yes, we are looking at all types of scrap, electronic scrap, magnets, batteries, really anything that has a very high content of these critical minerals. You can think in just one cell phone, we could pull out the lithium-ion battery to get the cobalt and nickel, the speaker and the receiver in your, say, your iPhone. That's all rare earth material, which is the materials that go into these permanent magnets, they call them, that power big wind turbines. So there's massive magnets in these wind turbines that power those big blades. They're the materials that go into EV motors. There's multiple components that we can get out of just say one phone or one laptop or even one EV that we can contribute back and pull back into that supply chain. So yes, going after many different feedstocks within the scrap space.
What is some of the best feedstock? What are some of the things that they mine for that we really don't think about? A lot of cell phones, right?
Absolutely. I call it sort of urban mining, right? Any electronics that we can get our hands on, whether it's a battery or a circuit board or the magnets I mentioned, they're all really high in terms of their metal content, we call it, compared to raw ore. So raw ore, I think it's like usually less than 1% in terms of the total metal in, say, a rock that you'd pull out of the ground. Whereas in a lithium-ion battery, you have 20 to 30% of metal in there, right? So it's a much higher grade feedstock. So that's really why there's been so much movement in that space, is because that's really the high content materials now that are easier to process.
Yeah. And let's talk about you for a second. So you and your co-founders developed this technology, I believe, at Yale. And then when you graduated, you started Ncycle. So how has it been transitioning from a university setting to a business?
Yeah, we did develop the technology while I was at Yale, and my co-founder had developed it a little bit at Harvard as well during his time. And so I would say the transition for me, at least, I would say a founder's journey is never easy, but I've quite enjoyed the transition. I went into graduate school to get my PhD knowing that I wanted to work on world-changing technology, but I never wanted to be a professor. I never wanted to be, a traditional industry player. I really always knew that I wanted to do something with my science communication skills, as I like to call them, as well as sort of my drive to make change. And I didn't really know what that would look like. The pieces fell in place for me to start this company, and I sort of took the opportunity when I saw it. I would say this journey was very welcomed, and I was very excited to take it, but definitely not an easy one. We've definitely had to find the right folks to build out the team, not only on the business development side of things, but also on the finance as well as the operations. And so finding that team and the right folks for the team was a really big milestone and achievement of mine over the past couple of years.
Sure. And I've talked to a couple of companies like yours in the past where it's early days and you've got a technology that, oh my gosh, can be used so many different ways. And we've talked about the battery stuff, we've talked about the electronics, and then there's all these supply chain issues we're having right now where there's a lot of focus on how do you make these rare earth minerals for chips more available. So it would seem to me that, Megan, you're probably getting pulled in a lot of different directions. So how do you focus what you want to do in the beginning?
Yeah, absolutely. And that is definitely something we faced in being able to process all these feedstocks. Like you said, we've gotten a lot of inbound interest from all sorts of directions, and we just didn't have the bandwidth, right, to look at all of them at the same time. So we really had to focus on the market opportunities and where the near-term opportunities were the strongest. And that's why we're going after the battery recycling space first, is because there's so much movement in the space. There's a lot of not only capital from industry going into it, but also from the government, right, and the new administration standpoint. So we felt that that was the best near-term opportunities for us, because it is an easier feedstock to process. There's a clear market fit and need for a technology like ours. And then we actually have a whole team dedicated, which my co-founder leads, looking at all the other feedstocks that customers have asked us about so that we can line up those in the years to come.
Yeah, there's a lot out there. Megan, you're also working with Clean Energy Ventures, I believe, from what I was reading. They were one of the first people who invested in you guys. I'll just name check that I've interviewed Connector and Line Vision, who's also been a beneficiary of them. What have you gained from that relationship?
From Clean Energy Ventures? Yeah. So working with them has been phenomenal. We were very, I would say, conscious of who we chose as our first investors, right? Because we didn't want sort of, I hate to call it dead weight on our cap table, but I think that's a lot of times what, if you take bad money, that's what happens. And so we really wanted a venture firm that not only could give us the capital that we needed to scale quickly and execute on all of the different milestones that we had laid out for ourselves, but also the resources that we needed, right? Because as you mentioned, we are an earlier stage company. We've been around for just over 4 years now, but still, in the early development phases of the commercialization pathway. It was really critical for us to find somebody like Clean Energy Ventures who could provide us with the connections. So that Clean Energy Ventures was able to help me find all of the team members I mentioned. So my finance person, my operations person, even my executive assistant and beyond. So they've been really helpful in actually building out the team with folks with really great experience in the startup space, as well as finding other forms of capital and even things like marketing, right? Things that you wouldn't necessarily think of that are really critically important at this stage of the business. And so we've been very fortunate to have them on our team and moving forward.
Yeah, well, it certainly sounds like you'll have no shortage of opportunities out there in the years to come.
Absolutely.
All right, Megan O'Connor, InCycle, thank you so much for your time.
Thank you so much for having me on here today. It was a pleasure.
That was Megan O'Connor, co-founder and CEO of InCycle, an electro-extraction company based in Massachusetts. I want to thank Megan for her time, as well as Colin Mahoney at Mahoney Communications for setting this up. This is our second collaboration, and it's always great to work with partners again. You can find plenty of pictures for this episode on energy-cast.com, as well as on Instagram and Parler at Host Energy, and Twitter at Host Energy Cast. All guests are sent the raw and completed audio the week of release. So far, no complaints. Be sure to leave us a positive review on iTunes. That gets the word out. Music was produced by Sean Stroop at Stroop Loops. That wraps up episode 128. Be sure to join us next week when we learn how non-visible light is being harnessed for next generation Windows. Until then, I'm Jay Downhauer. We'll see you next time.